Hello, and welcome back to BlessedMath. Remember, you can visit us at www.blessedmath.com for more of your Atlanta-based tutoring resource needs. So, today we're going over Lesson 2, our second part of our Systems of Equations and Inequalities tutorial. So, last time you visited us in Part 1, we talked about how to check if a point solves a system of equations, and we also took two lines, graphed them on a coordinate plane to find their intersection, because we know where they intersect is the point that solves both equations. And we also found that when we have parallel lines, they never touch, so they never intersect, thus they have no solution. So today we enter Part 2. We're going to be learning some new techniques for solving systems of equations. Pow! The ninjas. Gotta love the ninjas. All right, so the first technique that we're going to learn is substitution. So we're going to use the substitution method to solve two equations. So we have y equals x plus 4 and y is equal to 3x. Well, whenever we have y being equal to x plus 4 and y being 3x, just specifically telling us what y is two things, we're going to set those two things equal to each other. So I'm going to take y is equal to x plus 4 and y equal to 3x. So I'm just going to say 3x is equal to x plus 4. Now, in that case, I've rid the equation from the y. I can solve for the x. So I'm going to subtract the x from the right-hand side, and that's going to give me 2x on the left. And then I'm going to have 2x equal to 4. In order to remove the 2 that's being multiplied by x, I'm going to negate it by dividing it. So I'm going to divide both sides by 2. 2x divided by 2 is x, 4 divided by 2 is 2. Now that I know one of the variables, I'm going to substitute it in to solve for the other variable. Substitute. So y is equal to x plus 4 was one of our equations. Let's put x in now. We know what x is. Y is equal to 2 plus 4. 2 plus 4 being 6. So we can say that y is equal to 6. Well, now this gives us a point. We have the point 2, 6, 2 being x and 6 being y. And we're saying that that 2, 6 solves this system of equations. So if we say 6, looking at the first equation, 6 is equal to 2 plus 4, 6 is equal to 6, that is correct. If we say 6 is equal to 3 times 2, that's the same thing as saying 6 is equal to 6, that's correct. So the system of equation is solved with the point 2, 6. Example 2. We have y is equal to negative x minus 5 in this system of equations. And we have the second line, y is equal to x plus 3. So we have y being negative x minus 5 and y being x plus 3. So it's safe to say that negative x minus 5 is equal to x plus 3. So when we take those, we're going to solve our equation for x. So I'm going to add x to both sides to negate the negative x on the right, giving me 2x. And then I'm going to subtract the 3 from both sides, giving me negative 5 minus 3 as negative 8. And 2x equal to negative 8. Divide both by 2 to eliminate that 2 coefficient in front of the x, gives me x is equal to negative 4. So now that I know what my x is, I'm going to plug it into my y is equal to negative x minus 5, that first equation I have up there. Remember, I know what x is, so it's really y is equal to negative 4 minus 5. And negative times negative 4 is a positive 4. It's the same thing as saying negative 1 times negative 4. So y is equal to positive 4 minus 5, and a positive 4 minus 5 is the negative 1. So now I have x is equal to negative 4 and y is equal to negative 1. I have a point. That point being negative 4, negative 1. And this is the solution to the system of equations. If you pause the video and plug those in, you'll see that they do solve. As we go through, if you ever need to pause, just take a moment, plug them in, see if it checks out, and then we'll keep on moving. So let's get into some more techniques for solving systems of equations. Negative x plus 2y is equal to 8 and 3x minus 2y is equal to 4. We're going to do some addition and subtraction to cancel out these variables. So what I notice is the 2y and negative 2y are opposite signs of one another, which means if I add a positive 2y and I take away 2y, it gets me back to 0. So I'm going to add these two equations all the way across. That gives me negative x plus 2y equal 8 plus 3x minus 2y equal 4. So I'm just going to add straight down. Negative x plus 3x is 2x. 2y plus negative 2y is 0. And 8 plus 4 is 12. As I start to solve for x, I simplify. It's the same thing as saying 2x is equal to 12. I'm going to divide by 2 to negate that multiplying of the coefficient in front of the x, so I can get x by itself, and I have x is equal to 6. Now the good news, once I know x is equal to 6, I can just substitute it back in. So let me take the negative x plus 2y equal 8 equation, and remember x is 6, so it's really saying negative 6 plus 2y is equal to 8. So I'm going to solve this so I can figure out what y is. So I'm going to add the 6 to the left side. I'm going to add 6 to the right, giving me 2y is equal to 14. And in order to negate that multiplication of the coefficient, I'm going to divide by 2, giving me y is equal to 7. So I have the point 6, 7 as the solution to the system. Take your time, pause the video, and see if you can plug it back in to see if negative 6 plus 2 times 7 is equal to 8, or if 3 times 6 minus 2 times 7 is equal to 14. All right, we have x minus 2y is equal to negative 6, and x plus y is equal to 3. This time, I see a positive x and a positive x. They look the same. I know that I can subtract two identical terms to eliminate them. So x minus x is 0. So because the coefficients of x are the same, being 1, but we're not showing it, we're going to subtract the equations. X minus 2y is equal to negative 6, minus, in parentheses, x plus y is equal to 3. Make sure when you subtract that you distribute that minus sign through to everything in the bottom. So we're going to do x minus x, negative 2y minus y, and negative 6 minus 3. Giving me x minus x is 0, negative 2y minus y is negative 3y, and negative 6 minus 3 is equal to negative 9. Now I'm going to solve for y. Simplified, I have negative 3y is equal to negative 9. I'm going to divide by a negative 3 to get rid of that negative 3 coefficient being multiplied by my y on both sides. So I have y is equal to negative 9 divided by negative 3 of 3. Now that I know y is equal to 3, I can substitute it back in for any of my equations and solve for x. So we have x minus 2y equal negative 6, but we really know that's the same thing as saying x minus 2 times 3 is equal to negative 6. And 2 times 3 is 6, so what I have is x minus 6 is equal to negative 6, or you could also say x plus negative 6 is equal to negative 6. Either way, I'm going to add a 6 to both sides to get rid of the negative 6 on the left, leaving me with x is equal to 0. So what I say here is the x is 0. I still make sure I put the x in front and the y comes second. So 0, 3 is the solution of this system of equations, which means it satisfies both equations. Join us next time as we learn even more techniques for solving systems of equations. Once again, this has been BlessedMath, an Atlanta-based tutoring resource. You can visit us for more lessons and more information, and to contact our awesome math tutors at www.blessedmath.com.